Today I want to take you through how to solve frustrum of a cone, the volume of a frustrum of a cone by using integration method. Yesterday I did by using other formulas. Today I want specifically to talk about integration method. Now you can realize the question I'm given here is that to find the volume of the frustrum below. This is the frustrum I have with 42 centimeters, and this is a packet of 42 centimeters. The height is 20 centimeters, and the diameter of the upper side is 14 centimeters. So what you do for you to solve in using integration method, you have to draw now the y and the x axis, and then you draw this figure there, like I have done here. This is the y axis, the y and x plane. You draw the y axis and the x axis. And then the lower part you draw, make sure it is divided into two. The y-axis divides this packet into two on the lower part, which had 14 centimeters. So if it divides it into two, then 7 centimeters there, this other side, and 7 centimeters this other side. So if we have 0, that means this side is -7 and the upper side is +7, because that was the radius. And then the radius here becomes, it was now diameter is 42, so the radius here is 21 from here to here. So that means if you've drawn like I've done, you've drawn the same packet but on the x-axis plane, on the y-x plane. And therefore, you can find the coordinates, because we want to find the gradient of this line. We want to find the gradient of this line. The gradient of this line, so that we find the equation of this line. So the gradient of this line for us to find, remember the coordinate upper, the x-axis here is 0, the x-coordinate here is 0, and the y-coordinate is 7. And here, the x-coordinate, because from here to here is 20, from here to here is 20, and therefore the x-coordinate is 20 and the y-coordinate is 21. And therefore we can find the gradient. We can say that gradient equals to change in y-axis or change in x-axis, which is equal to, we are finding the gradient of that, so that we find the equation of that line. It will be equal to 21 minus 7 all over 20 minus 0. This gives you 14 out of 20, which is the same as 7 out of 10. From there, we can easily find the equation of that line without even much ado, because you realize that here we have the y-intercept, and we know the equation of a line is in the form y equals to mx plus c, where c is the y-intercept. We have the gradient, we have the c, so there is no need of struggling. So we will say that our equation is y equals to 7 all over 10 x plus c, which is 7. So that is our equation. So if we have the equation, we go further and use this formula. We use this formula to find the volume. So we say that Vx equals to integration of, that is from A to B, of y squared, that is dx. So meaning we integrate that from here we have is from here to, that is our x was changing from 0 to 20, so it is from 0 to 20, that is from 20 to 0. And then y squared, our y is 7 out of 10, x plus 7, we square this, dx. So that means we shall have our, there is a pi here, there is a pi, so our Vx equals to pi, integration of, we integrate, this one we square, we use this formula, that a plus b squared equals to a squared plus b squared plus 2ab, 2ab plus b squared. We use the same concept here, then this becomes 7 over 10 x squared, so it will be 49 out of 100 x squared plus 2 times 7 over 10 times 7, 2 times 7 over 10 times 7, it will give you, that is, if you multiply 2 times 7 over 10, then times 7, it gives you 49 over 5. It gives you 49 over 5, that is x, then plus 49. So this is what I'm integrating with respect to x, dx. That's what I'm integrating with respect to x from 20 to 0. So now we integrate, that means our volume will be pi. We integrate this. If you integrate this, the power is 2. You add 1, the power becomes 3, and then you divide by the new power. So it becomes 49 x cubed all over 3 times 100, because you need to divide by 3. So times 100 gives you 300, then plus 49, the new power becomes x squared all over, now 2 times 5, which gives you 10, then plus 49x, because the power x had a power of 0, and therefore x, you add 1, it becomes x power 1, x power 1 is x, and that is why we have it here. Then from 20 to 0. So our volume equals to pi into if you cube this, this is 49 brackets, we use now 20 there, we substitute, that is 20 cubed all over 300, then plus 49 all over 10, this is times 20 squared, then plus 49 times 20, yes, that is power 20, 0. Now, good. That one, first of all, we substitute, then we minus 0 times everything will become 0. So you're going to minus 0, because you need also to multiply, to subtract this, the upper minus the lower. The lower also you substitute with everything there. So if you substitute 0 with everything, it becomes 0. So minus 0. So you do this one, it will be V equals to pi into, you do that is 20 cubed. 20 cubed times 49, then you divide it by 300, you will find 1306.666 recurring is the same as 2/3. 1306 and 2/3 plus, this is 49 times 20 squared, that is 20 squared times 49 whatever you will get divided by 10, you get is 1960, then plus 49 times 20, 49 times 20, you get 980. You minus 0, so our pi is, if we were to take pi to be 22 over 7, 10 times, you add all this. If you add that, you get plus 1960 plus 1906.67. You'll get times 4,246.67, that is on the 2/3. And the 2/3 we times, when you times the 2, you get, that's times 22 over 7, you'll get it as 13,346.66 recurring, so it's the same as 346 and 2/3. When it recurs, you just write it 2/3 centimeters cubed. So that one becomes the volume of the figure, the volume of the figure. If you do the same question by using the method I showed you yesterday, if you apply this formula, you get the same answer. Just do it and see and confirm. If you use volume equals to a third pi h into brackets, whereby h, it's this distance from here to here. That is into brackets r squared plus r plus r squared If you apply this formula, you get the same answer. You get the same answer, that is 13,346 and 2/3 centimeters cubed. You can try that to prove my working. Thank you for listening, and ensure you subscribe to my channel. Thank you.